cake. I bet you guys are jealous. Is it necessary? That was legit. Okay, so the power law yesterday. I'll just go on to it. If I had log of 5, that just go 10 plus log 5 of, we good? 25, sure. So if I'm adding two logarithms with the same base, what did my product law tell me? Multiply, so can I write it like this? And then multiply what? The 10 and 25, so multiply my arguments of 250. Good. You know my product law. If I have log. Is this just like an overview? Yeah, I'm just going over this quick. Let's go 75. I'm just making stuff up. So if I have log of 75 base 5 divided by log of 25 base 5, what do I do here? Oh no, I'm supposed to subtract, sorry. We're subtracting, not dividing. Minus log. What do I do here? Yeah, now I divide. So log of 5, or base 5 of? Yep. So my quotient law is if I'm subtracting two logarithms with the same base, I would divide my arguments. Product law, if I am adding two logarithms with the same base, I would multiply my arguments. Okay? Alrighty. So that was yesterday. Is everyone okay with what we did yesterday? Yes. Is your calculator out of batteries? Oh, Michaela's. Hi, Michaela. I'm not going to go over that. That's fine. We let it slide because you brought cake. Okay, so investigating power law by writing 2 log x as log of x plus log of x. Show that 2 log x equals log x squared. So if I have 2 times something, that means I'm adding it to itself, right? It's the same thing. So if I have log of x plus log of x equals log of x squared, that's just, log of x squared. We got to prove that the left side equals the right side. When I'm adding two logarithms with the same base, what do? When I'm adding two logarithms with the same base, what do? Multiply what? Multiply the argument. So I have log, what is x times x? X squared equals log of x squared. So some questions will get you to prove that some things are equal or show that they're not equal. How are you, Michaela? So prove that 3 log of a base 2 equals 3 log of a cubed base 2. Same idea here. If I have 3 times something, I'm adding to itself how many times? If I have something times 3, I add it to itself how many times? 3. What the heck? So I have that plus page 270, Michaela. Yeah, so now that I'm adding all these logarithms, I have all the same bases, I multiply my arguments. What is a times a times a? Yeah. Oh, 2 of a cubed equals. Does everyone agree? Okay, so if I have, did someone just come in? No? I don't think so. Oh, Garrett did, yeah. Okay, so if I have a times log of c base b, there's a common correlation. So you can see if I have this number on front being multiplied, that would be my new exponent. Same with here. So this number on front is actually that exponent. So I can rewrite this of log of c base b, but this would be c to the a. So this number on front just turns into this new exponent. If you don't remember this, you could just put this, like if I give you this question right here, part B or part A, then you could just write it out like that, okay? Just write it out, and you just know that product law, if I'm adding logarithms, you always multiply the arguments, okay? So if you do that, you'll be fine. Are there any questions? Okay. Michaela, let me know when you got this written down, okay, and I'll move on. Oh, you got it? Oh, perfect. Garrett, did you get it? Garrett, did you get this? Okay, let me know when you're done. Yes, thank you.
Okay, I'm done now. Actually, I did. I took one after I realized. Allie took a bite of the cake and the cake was gone. Oh, okay. Good. Oh my God, Dylan. You destroyed the cake.
Oh yeah, don't defend yourself, you dirty. He thinks he's funny.
What are you watching this weekend with Scarlett?
Volleyball, and then I'm going to Calgary Sunday. No, I have that 3-day convention or conference or whatever. Probably not. I go up on a bus. Did you get it? Still copying? Got it? Okay. Okay, power of logarithms. So, we just wrote down that general rule. So if I have a number out in front, it'll be that new exponent. But you can also go the opposite way. So if I give you a logarithm and the argument has an exponent on it, you can take that exponent, this n, and move it out in front, like this. That's called the power law. Okay? Star this, know this. Okay, so now we're just going to write these guys. Quiet. You're going to write these just in the form n log x. So my n is my 10. I'm just going to move that out in front. So this would change to 10 log x.
What? Okay, why did you... Oh, never mind. Okay, that makes sense.
I'm putting it in this form. This is my rule. So I'm just taking this exponent and putting it out in front.
So is the next one 1/2?
We'll get there. We're building what?
The next one 1/2?
Yeah, well, I'll just write this as log. If I ever have the square root of x is equal to x to the 1/2. Okay, this is something you're going to have to know. So if I have the cubed root of x, this is equal to x to the 1/3. Okay. So this is equal to log of x to the 1/2. So 1/2 is my exponent. When I move it out in front, this would then be 1/2 log of x. Okay. So now let's go the opposite way. Yeah. So now we just take this out in front and put it as our new exponent. We're going to take on this next one, part B, take that whole negative 1/3 all the way up, okay? So this will be log x to negative 1/3. If I were to write x to the negative 1/3 without a fraction exponent, it's not asking us to do this, but I just want to make sure you know how to do this. Okay, so this 1/3 I know is a cubed root, but what happens if I have a negative exponent? What do I do?
Can you put the 1 over?
Yeah, put it under 1. So this is actually equal to 1 over x to the 1/3. And then if I were to write this in a radical way, it would be 1 over the cubed root of x. So you could either write it like that or like this. If it doesn't specify, just leave it how we left it. But I just want you to make sure you know how to do that second part. Okay, you have to know that a negative exponent means put it on the bottom, and that a fractional exponent means a radical,
So just
a root.
those fractions, you just write log or what?
Yeah, so you would write this as log of 1 over the cubed root of x. Any questions so far? Okay, so it wants us to write the following in the form n log x base b and evaluate. To evaluate, I'll just do the first one, show you how to put in your calculator, and then we're not going to evaluate, we'll just put it in that right form. Okay, so first off, let's take that exponent and put it out in front. So what do I write here? Right? Good. So to evaluate this then, in your calculator, I had my grade 10s asking what a logarithm was, and I was like, oh, that is my, because I had it on the calculator. So I was like, oh, that's my grade 12 stuff. It's like, why would you use that same calculator? Like, do I need a new calculator for every class I teach? It was funny. They're idiots. So 2 times. And then if I have if I have a base that's not 10, you go log of 8 divided by log of 2. Enter. So you could do this. If you wanted to leave the squared there, it should work. So if you want to just evaluate that without putting the 2 out in front, see how that goes. So 8 squared divided by log of 2. Okay, so if it doesn't tell you to put it into this form, you could just put it into your calculator like this, and it'll give you the same answer. So we're going to see that? So you could just leave that squared in when you put it in your calculator, and it'll give you that same answer. So this is equal to 6. Okay, so it doesn't ask to write into that form, then you don't have to. Okay. Okay, this next one. If I have 6 in front already, it means I'm going to multiply it by whatever I'm putting out in front after. So this 3 comes out here. This is the same as 6 times 3 log of 7 base 49. Okay? So if there's already a coefficient out in front, you would just multiply it, okay?
So then 18 log.
Yeah, so this would be then 18 log of 7 base 49. Did I lose you? Good. Good, good. Okay, so this next one, that's right. That radical as a fraction. So we have 6. If I have the cubed root of 7, I can write that as 7 to the exponent what? The cubed root. If I have a cubed root, what would my exponent be? Get rid of the root sign. 1/3. Everyone okay with that step? Yeah? Okay, so now bring it out in front. So if you want to just times 1/3 by 6 right off the bat, that's perfectly fine. So what's 1/3 of 6? Yep. So 2 times log of 7 base 49. Yeah, so 1/3 times 6 is 2. I just skipped a step there. One-third, because the cubed root, if I come up back up here, if I have the cube, what I'm circling, the cubed root of anything, you can write the cubed root as an exponent of 1/3. What I circled, do you see that? That's just a rule that we did. So then that's where we got this. Oh, you could just put these in your calculator, fine. I'm not going, I know you know how to use your calculators by now. If you are unsure with how to use your calculator for this, let me know, okay? If not, I'm going to assume that you do know how to do it. Okay, this next one, I have an exponent n. Can I just move the n out in front? Yep. What happens if I have the base and the argument the same? What will that be all the time? 1. If I have the base and the argument the same, so log of 6 base 6, that's just going to be equal to 1. So your answer here will just be n.
That's all it equals?
Yep, so that final answer is n. These ones will have number answers. So this one, do you want me to tell you? 9, yeah, and then this one will be 1. Okay, use the power law to prove that log of 16 to the x base 4 is equal to 2x. Okay, so let's work this out. If I have an exponent on my argument, what is my first step? Do it to the front. So what should I write this as? Oh yeah, it doesn't matter. So that is the same as, it's the same whether it's in brackets or not. If there's stuff going on inside the brackets, if it was like this times 5 to the x, then you would.
Oh, okay.
Okay, so just because it's in brackets doesn't mean you do anything differently. So how do I write this when I move my x? Get rid of my exponent? 16 base 4. Okay, so that's proved that our right side equals our left side. So log of 16 base 4, you can either put into exponential or you can put it in your calculator. So you exponentially, log of 16 base 4, I'll just go over this quick, set it equal to a variable. So you go 4 to the x equals 16. Yeah, so you could go 4 to the x equals 4 squared, and then x equals 2. Or you could see, if you could see that 4 squared is equal to 16, you could say that x equals 2. How do you get rid of the log? Did you figure it out?
How'd you do that?
How did I go from here to here? This was what we did yesterday and the day before. Changing from logarithm to exponential, you always use the same base.
Yeah. Okay, sorry.
The exponent will be the previous value, and then it'll equal your argument, okay? So this, going from this step to this step, you have to know that.
Yeah, I totally did not.
Does that make sense? And then normally you would go, I'll just do those steps. Normally you go 4 to the x equals 4 squared, write it with the same base. So once you have the same base, set your exponents equal to each other. Okay. Or you could just go log of 16 divided by log of 4. So you would have x then times 2 equals 2x. Does x times 2 equal 2x?
Yeah.
Yeah, so that's how you prove that.
Okay. Oh, okay, yeah, you just put in your calculator.
Yeah, so you can either do it exponentially or you could just put this in your calculator. Doesn't matter.
Say 2x in it?
Yeah, so then you'll say 2x. No. You would put this in your calculator, and this would get 2. Your x just carries down.
Oh, okay.
We don't know what x is. Okay? Any more questions? No, we good. Okay, lesson 5 is really quick, so we should be done this fast.
Okay. Oh, wow, it is pretty thick.
So lesson 5 is just basically a review of all our laws. Come on, there we go. So it's talking about the product, quotient, and power laws. You're going to have to know these. Oh, I already have. Let me erase this. This is mine from last year. I don't think it's that easy. Come on. What? Who are you talking to? Oh, they're talking to me. And I was like,
Wow, girl.
are you kidding me right now? Yeah, I know. I'll make you cry too. When's my first one of the day? Okay.
2 grade 8.
2 grade 8s I made cry. Well, I didn't make cry. They were just crying. There was a girl and a boy. Okie dokie. Lesson 5. Moving on. Star this. Know this. Okay? This is what you're going to be tested on. These are just rules you're going to have to know.
What?
Highlight. Whatever. Whatever mnemonic you want to use to study. I don't care. Don't care. Okay, students are asked to express 4 log of 2 base x minus log of 8 base x in terms of a single logarithm. The work of 3 students is shown below. Only one determined the right answer. Determine which student. What? Okay, so there's a couple ways you could do this. You could either do it on your own and see which one got your work, or you could just go through them and see which ones were right. What do you guys prefer to do?
The first option.
Do it on our own and see which one is right?
Or actually, no. I
You guys want to go through the rest and then we could point out the mistakes?
Yeah.
Okay, we can do that. Is everyone okay with that? Going through all of the work and seeing what's right or wrong?
Yep.
Okay. 4 log of 2 base x minus log of 8 base x. So they're saying that 4 log of 2 base x minus 2 cubed base x. So all they did here was change 8 to 2 cubed. Is everyone okay with that?
Yeah. Why would they do that? Yeah, why would they do that? You don't have
You can rewrite 8 to 2 cubed.
to. Oh, and then
You don't have to, but we're just checking their work. It's right, right?
Yeah.
Okay. All we're doing is changing 8 to 2 cubed. This is right.
Yeah.
Check mark.
It's all right. Allie, hold your horse.
Okay, so now that I have 2 cubed, I have an exponent on my argument. I can move that out in front. So 4 log of 2 base x, that stays the same, right? Minus, and then all we're doing is moving this 2 out front. Is that okay? Minus 3 log of 2 base x. Does that look okay? Just wait, just wait. Does this step look okay? This is what I'm on still.
Yeah.
So all we're doing is moving that 3 out in front. That looks okay.
Yeah.
What?
No.
I have 4 log of 2 base x minus 3 log of 2 base x. Is this right here the same as this right here? So if I have 4 log of 2 base x, can I subtract 3 of them? Yes.
Yeah, see it was right.
So if I have,
I could divide it.
okay, let me go, so let y equals log of 2 base x. This might help you out here. So then this right here, I'm just going to scratch this out, would equal to 4y minus 3y. Now can you see that you can subtract it? So just because it's a logarithm doesn't mean you can't subtract it, okay? So can you agree that this is equal to 1y? And 1y would equal to 1, it would be log of 2 base x. So that's just proven that way. Okay. So you can subtract your numbers in front as long as your logarithms are the same. So if you have the same argument, same base, then you can just subtract like that, okay? So yes, this was right. Did everyone see that? Do you want me to re-explain that somehow? I'm not asking you. Sorry, do you guys get it, or do you want me to re-explain it? We didn't use the product law here. Oh no, we just used the product law for, or the power law for moving this 3 down. And then we didn't use the product or the quotient law. So in this step right here that I'm circling, since you have log of 2 base x for both sides, you can just subtract them. So how I did that was on the side I said let y equals log of 2 base x. So then from that step, you can just say 4y minus 3y. Do you understand that part? Yeah. So then can you go 4y minus 3y? So that'll just give you y, right? So the same idea with your logarithm. So you can have 4 log of 2 base x minus 3 log of 2 base x. So you basically just go 4 minus 3, which is 1. So you're left with 1 log of 2 base x. So this right here is correct. So we didn't actually use the product or the quotient law here. They just subtracted the coefficients because these were the same. Does that make more sense? Yeah, okay. So we'll just say Shane is correct. But we'll find the errors in these next ones. Oh no, hey.
What?
He just grunted. Okay, so the first one, they just wrote out the formula. So their next step, all they did was take just 4, move it out in front. Is everyone okay with that step? Does that look good?
Yeah.
So this looks okay?
Thanks, Dylan.
So log of 16 base x minus log of 8 base x. The only thing they changed was 16. Is 2 to the exponent 4 equal to 16? Yeah, so is this next step okay? Yeah. So now when it looks like they're using the quotient law, when you subtract 2 logarithms, what should you do to the arguments? Divide. So this should be log of x of 16 divided by 8, right? Yeah, so this should be log of x, or log of 2 base x. 16 divided by 8 is 2. So right here, this is where they went wrong because they didn't divide. Does everyone see that?
Yeah.
Okay, let's look at Clayton's work.
Right off the bat.
Yeah, so right off the bat, it looks like he multiplied the 4 by the 2. Is that right? No, so this is where he went wrong. Your phone? Oh my goodness, you don't have your phone on you? Okay, are there any questions with how to show whether these are right or wrong? See the errors? Everyone's okay with that? Okay. Class example 2. Write each of the following as a single logarithm. So there are things or ways we could do this with to write them all as one logarithm, okay? So looking at this first one, what? What should we do? Where should we start? You can't subtract them because your logarithms are not the same. You can only do it if your logarithms are exactly the same. You have these numbers out in front. Can we get rid of these numbers out in front? Yeah, let's do that. So how do I get rid of those numbers in front? We're not dividing anything right now. Yeah, put these as the exponents. Use our power law. So how can I rewrite this? What is my exponent though? Good. Minus. Good. Does everyone agree with that step? You ruined it. What? Yeah, so now let's keep going. So, yeah, so let's just figure out what log of 16 to the base, or to the exponent 1/2 and 8 to the exponent 1/3 is. So this would be log 16 to the exponent 1/2 is the same thing as the square root of 16. Right? Because if I have an exponent 1/2, it's equal to the square root. So this would equal 4. Minus, if I have 8 to the 1/3, what is that as a radical? Radical. It's a cubed root. If I ever have 1/3, it's the same as the cubed root.
Yeah.
Yeah, so this is 2.
Yeah.
Yeah.
Yeah, that's what I said.
I know, you just skipped a step. You didn't answer my question.
Oh, sorry.
Is everyone okay with that next step? So now when I subtract 2 logarithms, what do I do? Divide. Good. Whenever I subtract 2 logarithms of the same base, I divide the arguments. What's 4 divided by 2?
2. Nice. We're so smart.
Sorry? Okay, do this. Try this next one on your own.
I don't want to.
Okay? If there's a coefficient, guys, listen. If there's a coefficient, make it the exponent. And then if you're subtracting logarithms, divide the arguments, okay? So if it's just an a, leave it as a. So leave the first one as log of a. Yeah, the 5 will go up.
And log a to the 2 stays the same. So then could you?
There's 3 things happening here.
Okay, now I'm stuck. So then could you just subtract?
So then start with the, don't do it all at once. Do the first 2. Go left to right. So go log of a minus log of e to the exponent 5. So when you subtract 2 logarithms, what do you do to the arguments? Divide. Just go a over e to the 5. You're overcomplicating this.
Log over log a over e.
No, just log of a divided by e to the 5.
Oh, I was talking about the next step. I'm done this one.
That's what we talked about with the next step.
Whoa. Watch your mouth, guys. No. Guys, you're still in school. Okay. Yep. Yeah, it has to be just on the e.
Just on the e?
Just on the e. Okay, seriously, grow up.
I didn't even say anything. Nothing.
So I have
Nothing funny because there's nothing funny about that at all.
a over e to the 5, and then when I'm subtracting, I want to divide again.
Holy Lord.
But if I divide by something, so I have a over e to the 5, e to the 5. If I'm dividing by a squared, I could put this over 1, right?
What happened to your...
And then when you, what?
Oh, never mind. Okay, I got it.
When you divide by a fraction, it's the same as multiplying by the reciprocal.
Yeah. Oh my God.
Oh, no, I lied to you, Dylan.
Yeah, I was just thinking, what do you
Oh, so it'd be a times.
Is everyone okay with this so far? Everyone still with me?
Hold on.
No? Negative. Okay, what are you talking about? Negative 2. Oh, I gotcha. No, you would just leave it as a positive for now. We're not changing any of those. We're not changing any of those exponents right now. The only time you would have to worry about that is when you're trying to make the same base with the negative exponents. So if I have a divided by e to the 5, and I'm dividing that whole fraction by a squared, it's the same as multiplying by this reciprocal. Okay? So if I just flip that around, now I can multiply straight across. And then I can simplify. 1 over e to the 5 times a. Oh, sorry, 1 over. Yeah, this was a big question. This a, because this a cancels out with that squared. This is your answer. This 5 is an exponent. Okay, yeah, this was a big question, sorry. But if you know how to do this, you're pretty much, you've got quotients law down and the power law. Okay, is everyone okay? Do you want me to explain any steps that I did just now?
You better not.
Okay. Okay. Okay, write the expression 2 log of 4 base 6 plus log of 2.25 base 6 as a single logarithm. Then evaluate the expression. Okay, so every time we're writing as a single logarithm, if my logarithms aren't exactly the same, I do not add the coefficients, okay? So I have to get rid of this coefficient somehow. How do I do it? Every time you have that number in front, make it your exponent.
Gosh darn it, Dylan.
Okay, so we're making that exponent, so I have log of, can I skip a step here and just go 4 to the exponent 2 and write it as 16?
Yeah.
If I write this as 16, does everyone agree with that? No? Do you want me to write that other step?
No.
You're good? Okay. Okay, so now that I have 2 logarithms added to each other, same base, what do? I multiply, right? So this would be the same as log 16 times 2.25. What is log of 36 base 6? Well, it'd be 6 squared, but what is your answer here?
1? No, it's 6. 2. 2.
It's going to be 2. Because 6 squared is equal to 36. So as a quick check, guys, quiet. As a quick check, your base to the exponent of your answer should equal your argument. So 6 squared equals 36.
Ooh, what a check.
With a check. Okay. Okay, so log of p base 5 equals 12. That's what they're telling us. Then determine the exact value, okay? If log of p base 5 is equal to 12, this right here is equal to 12. Does everyone see that? So I can just go 5 times 12 if I want to.
60.
It's 60.
That's what you're doing?
Yep, so we're just evaluating these 3. So for A, that's all you do. Just because if they're saying log of p base 5 is equal to 12, if they go 5 times log of p base 5, it's just 5 times 12.
So then the next one is the same.
Now that we have that 5 in front of your p.
5 times 12.
You guys suck.
720. Oh, okay. I get you now. Is it 75? No, it's still
Nope. Okay, so this next one is tricky. Look at 5 times p. If I have two arguments being multiplied together, do we talk about something like that? Look at this one. So let's just go the opposite way. So now we're going to make them added to each other, okay? Does everyone see that? 5 times p. I can rewrite this as 5 base 5 plus log of p base 5. Yeah, which will be 12. Does everyone see that step? This is a big step. So my argument is 5 times p. So as soon as you have that multiplication, use the product law and split them apart and add the logarithms. Logarithms. My arguments are being multiplied here, so you're going to add the logarithms. Okay? So it's going to be 13 to 1, not 12. So log of 5 base 5, every time I have the argument and base the same, what is that equal to?
Yeah, how is it 13? Isn't it 17?
What is log of 5 base 5? Work with this now. 1. And log of p base 5 is 12 because that's what they gave it to us. So your answer here is 13.
That's confusing.
And you play basketball.
Okay, is everyone okay with this step? Kind of, sort of?
1 second. Give me 2 minutes. Okay, I can.
Do you guys have questions? Do you understand why I did that?
I'm not even going to guess.
Okay, log of 25p cubed base 5. Look at your arguments.
Oh my god.
Is your exponent affecting the 25 and the p or just the p? Just the p. So p cubed, oh my god.
So we have
P cubed is being multiplied to 25. So can we split that up somehow?
so 12 times 3.
No, don't get that far. Split it up into 2 logarithms. Sorry, what were you saying? If I have 25 times p cubed, how can I write this as 2 logarithms? Don't use 12. Just go p cubed. It's not 12 to the power of 3. 3 times 12. Eventually. Because as soon as so log of 5 base 5, can you evaluate that right now? Yeah, it's 2. Plus, I have an exponent on my argument. Where should I put that? In front. Plus 3 log of p base 5. Is everyone okay so far? What is log of p base 5 equal to?
12.
Yeah.
Where'd you guys know that?
It's right here.
Oh, okay. Okay, never mind.
No. It's not just p that equals 12, it's log of p base 5 equals 12.
Yeah, that's
Do you guys get that? So what is 2 plus 3 times 12?
apparently 38.
Stapler here.
Yes. It's over there. Okay, any questions? Okay, last one. Log of x base 2 equals a. Use the laws of logarithms to show that log of 32x squared base 2 is equal to 5 plus a squared. So let's go log. So let's use what we know. Is this squared affecting your 32? Just your x, right? It's inside the brackets. It's just beside the x. So I have 32 times x squared. Can I write this as two different logarithms? Yeah. How do I write that? Perfect.
What? Oh, never mind, I got it.
Whoa,
Does
man.
everyone see that step?
Why do I keep it?
You got it? Yeah. Log 32 base 2, can we evaluate that? Log of 32 base 2, what is that going to be? 2 to the exponent of what equals 32? 5. Oh, man. Okay, now I have an exponent in my argument. What should I do? Put the 2 in front. So now I have 5 plus log of x base 2. I can't simplify anything else from here. But look in your question. Log of x base 2 is equal to a. So this right here is equal to a. So I can rewrite this as 5 plus 2a.
Do you want to die, Dylan?
Any questions, guys?